Okay, welcome everybody. Lunch was good? Everybody is still awake? More or less? Okay, let's keep it that way. Let's see. So let's see where we can go with logging patterns and what you are doing with logging and maybe what pain points you have experienced. So at some point you probably start developing your program and everything is fine. You build and you see some stuff happening and then you try it out locally. Maybe you cat your logs and you see your logs, and some later point you might get a bit more advanced and then you just do tail F to follow around to see what your logs are doing. If you're more advanced, you might do less plus capital F. Anybody knows what less plus capital F is doing or what the difference is to the tail F? It's still following the logs, but you can break out of it and then you can just move around, search for stuff, and then you can keep following. Whereas with tail F, you have to totally break out the tail F always to get around and see stuff. So it's a bit more advanced and you're probably saying, this is fine and I can work with my logs. And at some later point on, you want to bring this to production and maybe you have more than one service or more than one server, and then you have something like this where you have 3 SSH sessions, for example, or you're trying to tail 3 containers, and well, you see parts there and parts there, so it's okay-ish. And then later on, maybe you have even more services and you get more and more windows. And at some point, you don't even know, like, where am I even and what is happening where. And maybe at some point, you also have where you have a largest log file and you just start to poke around the 7 GB log file to find the right stuff. And maybe this is not really where you want to go, how you want to spend your time. And at some point you maybe figure out everything is on fire, everything is terrible, logging is terrible. What is the solution for that? Like, how can we avoid the logging problem or that? So the idea is generally to log all the things and also to centralize all the things. So whatever your applications or maybe also your systems, but we'll stick to a Java application, is emitting, we want to collect that and just see how we can work in a sensible fashion with those logs. So that's the general idea. So why am I talking about that? So I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. We are kind of well known in the logging ecosystem, and yeah, I try to tell people, like, these are things that you might want to do to make your logging life easier, and these are things you might want to avoid, and these are just some pain points or things that we have seen. I do have a lot of material. I could probably fill 2 sessions, but we'll just pick some interesting parts and I'll point you sometimes in the right direction and you can look at further stuff in the slides. So, who knows the classical ELK stack? Elasticsearch, Logstash, Kibana. Who is using that for logging? Okay, quite a few. We're not really the classical ELK anymore. It is very widely used. So for example, any of these companies, and I've even updated the Slack logo, these little companies are using the ELK stack for logging, security logs, general events, like what just has happened. However, we have tried to evolve a bit further than the classic Elasticsearch, Logstash, Kibana. So you have Logstash to get the data and parse it, put it into Elasticsearch, which stores the data, and then Kibana to visualize it. But we've also added the component Beats at some point. And Beats is like a lightweight agent or shipper. It's maybe a forwarder. It's written in Go, so you have native binaries, you don't have any runtime dependencies, and you can just forward events, for example, logs from your service very efficiently to a central point. The problem is there is no B in ELK. We tried to come up with this. You can see that's the BELK or the ELK B, and you can see it has the ELK horns, it's a B. But since we're always about scaling, this is not very scalable, because what happens if we add another letter? Then we have to redo the entire branding. And branding is very sticky. You probably still get these recruiter emails where they ask for a J2EE developer, and that has been more than 10 years. And we don't want to be in the same position that we put out the ELK and the BELK, and then we have to redo the branding all the time. So now we just try to call it the Elastic Stack, because that's very scalable. Whatever products we have, we can just put them in there, and it's the same naming. But if you say ELK, we'll still understand, and it's the same idea, but it's kind of like taking some concepts a bit further and making stuff a bit more advanced, maybe. So the general stack is we have Beats to generally collect stuff, send it then either to Logstash, which can do the parsing or enrichment, which could do, or which can store it in Elasticsearch, or Beats sends data to Elasticsearch directly, and then Kibana can visualize that. Sometimes people ask, like, what is the data store behind Elasticsearch? There is no other data store. Elasticsearch is the thing that stores it on disk already. By the way, what do I mean when I say enrichment? What would enrichment be for your logs, for example? That I add some kinds of events. For example, you have an IP address and you want to do a geo-IP lookup so you can actually draw that on a map. And that's generally a concept that we have, that we do a lot of this enrichment at insert time. So when you store something, we will add the right metadata to make it possible to actually draw something out on a map. And the search query afterwards will be very fast because we have all the information already in the system. So we'll do a monitored, highly monitored, I don't know, hello world application. So this will be really simple. But you'll see various patterns of how things work out and what to watch out for in logging. So I'm using SLF4j as the logging facade, logback as my log appender, and then MDC to add some structure to that with the log/logback encoder. If you're on log4j, same thing, slightly different syntax, you can totally do that. There you need the log/layout or plugin, but otherwise it's the same thing. What was MDC again? What did it stand for and what did it do? Map diagnostic context is basically structured information that you want to add to your events. So for example, if you have a user that can log into your system, you might want to add to all the events that you collect the user ID or login name or whatever. So when somebody calls you and says like, your system is broken, then you ask like, okay, what is your username? And then you just look at the logs for that specific user, and then you see what was this specific user up to. And you can just filter down or drill into your logs. Like if you have this kind of structured information, it will be much easier to isolate relevant events and just drill down into the relevant pieces. If you're on any other platform, I assume most of you here are using Java, so this is what we are using for the demo. But even if you're using PHP, there is no excuse not for doing logging properly. Even PHP has a proper logging appender nowadays. So everybody is covered here. It's just slightly different syntaxes or technologies. Two things we want to avoid. The first thing is we don't do println or anything for logging, right? Because you don't have log levels and it's just the wrong thing to do. So we want to avoid that. The other thing we don't want to have is we want to avoid very direct coupling between your logging centralization and your application. So you don't want to have one super specific dependency that just sends to one logging backend, because if you want to replace your logging backend, you would need to redo your entire logging infrastructure. If you have that over all your classes, you probably don't want to do that. So you want to configure that centrally, probably in your log appender in one place. There you can switch it out. But you don't want to have any specific implementation details in your Java code because, well, switching that might be not so great in the long term. Okay, so let's start with the classical parsing. You have a log file and you chop up the file basically to extract the relevant pieces out of that. Who is doing that? Like you log to a classic file and then try to parse out information. 1, 2, not so many, okay. Let's see what we have here. So I have a super simple application. We have a loop that runs 20 times. I generate some session information, which is a random number, up to 99. And then I just add a loop count. So these are the two structured pieces of information. They could be like your user or whatever structured information you have in your real application. We'll just add those two pieces as a placeholder for structured information. And then we'll do a trace statement on every loop iteration. And afterwards, we do this kind of pattern where if something can be divided by 15, we'll throw a runtime exception. Divided by 5, we'll have a warning. 3, an info, and all other cases, a debug. What are we doing here? What is that pattern? Has anybody done a job interview recently? That's classic FizzBuzz, what, I don't know. I'm not sure if this is very popular around here to implement in your job interviews, but it happens every now and then that somebody wants you to implement something like that. So how many log events will we have in total here, given that loop? Who is for 19? Who is for 20? Who is for 38? Who is for 40? Anybody more? No, ideally it should be 40. We have 20 times, we run through this. We have one trace statement in each iteration, and then we have one other message in each count. So it should be 40, right? So let's simply run that. I've just thrown it in a Docker container. It will just run that. My entire setup is Dockerized, but it doesn't really matter for the details here. We'll collect that. This is, if you've never seen it, Kibana, and then we'll head over to Discover where you can actually see the events. And then, let's keep refreshing here. And then you can see here, structure is the wrong index. Actually, I did call it Parse. We should go to Parse. So here you can see we have some events. Let's zoom into that area, what I've just done. And then you can see now we have 42 events. Why do we have 42 events? Didn't we say it should be 40? Was anybody for the more events than 40? Why could we have 40? Sorry? Yeah, what about the runtime exception? Yes, so let's see. I'll extract the log level here, so I'll just put that next to it so we just see the log level, and then you see we have all kinds of statements. And then we have two lines, this one and this one, which doesn't have a log level. And when I open it up, you're exactly correct, this is part of my runtime exception, which has exactly 2 lines in the stack trace, and then I collected those. Is one line of a stack trace very helpful? Do you want to break that up? Normally not, because one line of a stack trace is not telling you anything. So what are we doing here and how can we fix that problem? So the general idea is you have your log file, then you have filebeat, which is basically tailing that file. It sends it to Logstash. Logstash is doing some parsing for us, so it will extract like the log level and the class and the method and that MDC information. It will parse it out again, and then stores that into Elasticsearch and Kibana. Where would I make sure that I don't break up my stack traces? Generally as early as possible. So where you want to do that is in filebeat. You want, when you collect it, you don't want to break up the log lines, because by default it would say like every line is one log event. You don't want to do that. You want, for some events, you want to say like, well, this is a stack trace, this should be one unit. And if you don't break it up in the first place, it will be much easier to handle afterwards. Otherwise, trying to combine something together after the fact is always harder. So you want to keep that in one line or in one element. So what you basically have to do is, let's quickly jump over to the configuration. So we have filebeat for Logstash. What we do have is we're collecting our log files. And what we would need to do is, and I'll enable that now, no, these are the lines I want. We can say we have a multi-line pattern. And the multi-line pattern is basically, you can also see that down here. This is what my stack trace looks like, is every line starts with a square bracket. And if it doesn't start with a square bracket, at some point we'll have our runtime exception here. This one doesn't start with a square bracket. So basically, this is the pattern that we're looking for. If it doesn't start with a square bracket, it's the continuation of the previous line, and then it shouldn't be broken up. And you should wait for the next square bracket until you make another event. So this rule is basically saying that. So we are searching for something that starts with a square bracket, and match everything that is after that, and do that. You could have all kinds of combinations like negate and match. You can cover like 4 different combinations of how your log patterns might look like. This is the right one for this example, where we basically keep this one here together. And no, this was not the file I wanted. And this is keeping this together. And since I have this in the configuration folder, my configuration should have updated in the background automatically. So when I run my log events again, this should generate another batch of logs. And this time, hopefully, it should be 40. So let's say we want the last 15 minutes again. And if everything worked out correctly. Let's see, they're coming in. And you can see here we had 42, and here we just have 40 now. And if I fold that back in and say, let's zoom into those, because I'm only interested in those 40, somewhere we should have an error. If you spot the error, shout, because I probably just missed it. On the other hand, you don't have to spot it. Maybe you have too many. Then you have a log level. Somewhere there should be a level here. Where's my log level? Package loop. Oh yeah, sorry. I've used that in the past, so that's why I put it up here. In the log level, you see basically these are all the log levels that we have. I want to filter down on that one and then you have that one specific event. And in this one, you can see now the stack trace is one piece. We haven't broken it up. And this will make your life much easier. For the parsing, you basically need to write the regular expression to parse that apart. We have something called Croc to do that for you, which is in the named regular expression. Just to make that quick, how does that look like is, so we have collected the log lines, there are the Croc patterns, and you can simulate that in a so-called Croc debugger in Kibana. So you could add one log line, you can start putting together your log or Croc pattern, and then you would see how it would break out events. And this is how you could write that pattern to do that. And in the end, you will figure out that if you try this event, this here is the right regular expression to parse this apart. Who likes writing regular expressions? Anybody? Okay, this is probably the Stockholm syndrome, right? That you got so used to doing something that at some point you accept it and you embrace it. But this is one of the pain points here, that you need to write this regular expression. It's kind of unnecessary because your application has that information in a structured format. Then you write it out to a line, and then you write the regular expression to parse it back from that line. Not only is it a lot of work for you, it also has like some overhead in CPU to do all that parsing. So maybe we can avoid that. By the way, something we've also done is we have these MDC messages where we have multiple events. I have also broken those out. So if we look at, let's say, here, you see here we have this session and the loop. And I have parsed those out, also that user experience. Basically, key value always assumes you have something with an equal sign, and we've parsed it out as well. So yes, you can do all of that, but it's kind of a pain to do it and not super nice. So we have done that parsing. We have added recently something new, which is basically, machine learning is a bit of an overloaded term. You could also call it auto-grok. So what this does is you upload your file, and it tries to generate the pattern for you automatically, or give you a starting point, so you don't have to write the regular expression from scratch. I won't demo it because this is all you will get out of that. You upload your file, and this is the suggestion that it does here. You can see this looks good, this looks good. Here it is a bit unsure about how to parse some pieces of information, but you could then fine-tune that pattern, and with that you can basically have a starting point where to get started with your logging. And then it just shows you how to do that parsing. This was how to have that not breaking up the log lines into the wrong pieces with the multi-line statements. In the documentation is basically shown all the combinations of how you can combine those. Overall, the big advantage is you just keep doing what you have been doing. You have your classical log lines, and then you need to parse them back. Downside is you need to write regular expressions. Multi-line statements need to be taken care of, and anytime you change your log format, the output, you also need to change your Croc patterns. So you have a bit of a coupling between those two systems because you cannot change your Java application independently of your logging system. So it's maybe not super nice. Something that you could do instead is you could send the data directly via the log appender to Logstash, for example. Is anybody doing that, sending data directly to a log appender? One, okay. So what that maybe looks like is you have a special log appender that forwards it to Logstash, and then you just store it in the background. Basically in logback, all I'm doing here is I have that Logstash access TCP socket appender. This is an additional dependency. But all you need to do is basically say like, this is where Logstash is living, send all the data to Logstash, and you're done. So this is very easy. You just add that to your logback configuration. And what you then get is, let's throw this one out. We need the send index. So here, you see, we have 40 events. We didn't need to care about multi-lines or anything because the application knew. And then here you have one event. You can see we don't have that original message that we had to parse apart, but it has all the right pieces already nicely broken up because your application knows what is what and just sends it. So you can see we have the log level here, we have that iteration 1 and session 94, but it has also broken out the session 94 here nicely. You know where it's coming from, the logger name, you're pretty much done. So this is easy. What could be a downside of this approach? The main downside is like, what if your receiving system is not up yet? So if you've never established a connection, logback will just throw away the events. If it's not in the middle of running, if it's not available for some time, logback is buffering the log events. By default, I think that is 200 megabytes for logback. But once you hit those 200 megabytes, you will lose the oldest messages. And also, if your network, for example, is having a hard time, that's probably when you're most interested in your log events because bad stuff is happening. But exactly then you don't see your log events. So maybe this is not really what you want. So coming back here, you don't have any files, you don't have to worry about those, you don't need to do any parsing, but if your network is down or your receiver is down, you will not receive any events. And also you have a bit more coupling because your application now needs to know where does logstash live basically. And if you move the logstash server or use a different DNS name for that, you will need to update your applications. Not super tightly coupled, and it's only in the logback appender, but there is still some dependency that you have between the two. So maybe this is again not the best approach. What else could we do? Any suggestions? What might be nicer? So I'm lazy. What I would do is I would just write the logs in a structured format. Basically, I use a logback appender that writes out JSON because Elasticsearch can also store JSON, and then the file beat can basically just throw the JSON events into Elasticsearch and you're done, because you don't need to do any parsing. So in your application, what you have is basically the result will be you have, no, not the targz, I need the uncompressed one. So instead of having a log line that looks like this, let's make it structured. So basically you have curly braces and quotation marks and an attribute name, but otherwise it's exactly the same. If we scroll down, there will be one longer line, that is the stack trace. And if you scroll over that one here, you can see this was my stack trace. It's just \n\t. So it's all one line. You don't have to worry about multi-lines. You don't have to worry about parsing. It's just in the logback appender, you basically need to say here, I have a bit more configuration. So here I have the regular like file rotation and everything, but then I say, okay, this is, for example, the pattern, how I want to log and how the fields should be called. So you can just configure that. But otherwise, the file beat is just tailing that file and sends it onwards. And you're pretty much done. So if I head over to the structure, you can see here, 40 events, everything's good. If I open one up here, for example, you can see trace, or let's try to find where is my error again. This time I find it right away. You can see here, we have the stack trace, it's not broken up. We have even the user experience with the emoji, like we support emojis throughout the stack nowadays. So the most important things are covered. And you can see the loop and everything. Everything was an independent event and we have collected those. By the way, something that I've been doing all the time and haven't really pointed out is I have this host information. This is basically some enrichment that I have done from the start. So if you know you have some specific bug on one operating system, you could enrich that, or you know you have a security issue on one specific system, you could enrich that. If you are running in the cloud, we could also enrich cloud information. So we know, for example, which region or availability zone, which instance ID, etc. We could enrich that in your events. We can do the same for Docker and Kubernetes, but I will get to those shortly next up. So this is what we have collected. This was all easy. The only thing that you need to watch out for basically is, so you have your JSON file, you just tail the JSON file directly into Elasticsearch. You don't need Logstash anymore. The thing you need to configure is basically you need to tell FileBeat that this is a JSON file, that it parses it correctly. It doesn't assume this is just one log line, but you need to say like JSON under the key message. There is JSON, or put under the key message, put that thing that is JSON, and this is just structured JSON. So it will interpret that correctly. It will not try to throw it out as a line, but already parse it as JSON, and then store it the right way into Elasticsearch. And then you're done. So this is simple. One thing, yeah, I didn't really point that out. Stack trace hash. So if we have the error, this one is the error, we have here a stack hash. The stack hash is a feature of the log appender. It basically takes the stack trace, throws out stuff that is changing between requests. So for example, if you have reflection stuff, it might change the stack trace between calls. It throws away stuff that changes and then hashes what is in the stack trace. So you basically get a unique hash for each stack trace. And you could use that then to aggregate and see like how many unique errors do I have in my system, how many times did one specific error happen, and for example, if you have the user information, you could then see like how many users were affected by a specific stack trace, or how many users hit stack traces overall or whatever. So you can have something else to have a bit more structure, and you could aggregate that or graph that out, and you could also figure out like which is the most common stack trace. Maybe I want to tackle that first and solve that stack trace first. This is some just like a nice added feature that you have here that's basically coming for free. It's been done by the log appender, so it will have minimal CPU overhead, it will hash the stack trace, but add that to the output directly in the JSON, and you don't have to do any extra additional work around it otherwise. The good thing is you have the right format, you maybe have some slight overhead for JSON serialization and also for the stack hash. On the other hand, parsing back a log line is also not for free, so it's kind of a trade-off, and you need to measure like where does it make sense. Okay, so let's assume you containerize your application. I assume everybody is using Docker, right? Anybody using anything other than Docker to containerize? No, okay. So who is running the Java application inside a container? Okay, that's quite a few. How do you get your logs out of the container ideally? Or let's start somewhere else. Where do we run the file beat to collect it? Generally, we would say as a sidecar. So you have one file beat container, and that is checking what the log output of the other containers is. You don't have to bake it into the image. You could install it on the host, but it's not really necessary. That's a bit up to you. You can just run it as a sidecar. So what we are doing is so my application will now do the console output. So we are going to system out, which will add or end up in the JSON Docker log, the default one. Bless you. The file beat will automatically collect those JSON logs and then forward that to Elasticsearch and Kibana. We, by the way, have examples for that, both for Docker and Kubernetes in the repository of beats. So you can just find the configurations there. But here, what I'm doing is basically, we have something called auto-discover. So basically, we know you are running in or you have Docker running, and I know automatically on your operating system where those logs are. So I will collect them automatically. And with that processor, I can even add the Docker metadata. So the Docker metadata might be which base image do you have, which labels have you applied, which container name do you have, etc. So we can enrich that, and you can filter down on that. And here we're just collecting all the logs that my Docker containers are running. So let's switch over to Docker. Why do I have so many events here? I didn't run my application all the time. What is happening here? Like, what's up with all of these? Since I have a lot of containers running, I'm just monitoring all the containers, because I didn't say like just monitor on my Java container, but get all the logs in my system. So that's why we have a lot of events here. By the way, let's say quick. Let's say we want only events from the last 30 minutes. You can see we are collecting quite a few events over time. But since we have the metadata, we can very easily drill down on that. So for example, you could say we have a container.name, and the container name is, and then you can see somewhere we have a Java application. That's the one I'm interested in. And then I'm just drilling down into that. And then you can see here we have 39 events. Now this might be confusing. Why do we have 39 events? Why is the number always wrong? Anybody can guess what might have happened here? Why is it one too few, basically? First we had too many, now we have one too few. It's like, it's never right. So the problem here is, that is something that Docker is doing, unfortunately. When you open up a log file in that logback is producing, if I would see my log file here, and you scroll to the very end, okay, I've done this too often. You can see we have a new line here, which is empty. And the next log event will end up on that line. But we have a new line. And that is what FileBit is operating on. So it's basically waiting for a new line. If you don't do the new line at the end, it's waiting. So what we can do is we can run this again. Then we'll basically get the new line for the last event of that previous batch, and then we'll do the next batch, and only then will we get the last event because Docker is not adding that new line at the end in the Docker default logs. So that might be slightly confusing. Normally when you have a continuous log stream, you will not even really notice that because it's just like if you have every few seconds a log event coming in, the previous one is just appearing very rapidly. But with my 40 events, it's very easy to tell when something is missing and something is there. So let's refresh that, and you can see here, 40 events, 39 events. This is why this is happening. So you're basically always missing the very last one. But if you have a continuous log stream, this is not an issue. It's just like, where's the new line? Okay, so this is all good. Something, by the way, that I would avoid is in my log appender, in the console output, what is not uncommon that in the console output here, around the level you might have highlighting so that the error message is colored in red. But that will add then some ASCII characters in the raw output, which here will be colored nicely or on a shell. But if you collect that, you will need to have that in the parsing rules to throw out that coloring. So that's why I disabled the coloring on my console output, because this is what is ending up in the Docker log. And otherwise your parsing will get more complicated because, well, this is what we're collecting. So let's see, what else do we have? Yeah, you've seen, or did I really point that out? No, let me show that. We have the metadata. So if I open one of these events now, you see here everything starting with docker dot. This is the metadata that we have collected. So you can see, for example, this is somewhere we have the container ID, and basically this is also how we are doing this. So because the Docker log is in var lib docker containers docker ID / docker ID.json. And what we're basically doing is we're going to that folder, we see all these IDs, then we take the ID and query the Docker daemon and say like, hey, I have this ID, give me all the metadata for that daemon. And that's how we are getting to that information actually. And then we're adding all of that information. So for example, I've called this application FizzBuzz, and it's running in production because I've set my environment label on to that. So we're collecting all of that metadata. And you can also see we have the original message, and then we have parsed out the rest. And so this is working nicely, and you have the log level. So this is all nice, more or less, because I've made it a little simpler than it actually is in the background. So let's have a look. We've seen why the last line is missing. Something else that we still have here is the multi-line patterns. Normally we would have more events because the multi-lines would be broken up again. But here I've kind of like done a bit of an inversion of control. Rather than saying like, if you have this Docker ID, apply these rules, I have set these rules. These are the same rules that we've seen before when we did the parsing. So we had the multi-line, the pattern, the negate, and the match. And I'm setting that on the container. And the file bit will automatically pick up those rules when it sees a container with that metadata. So basically where this is happening, just to make this a little clearer, this is all Docker Compose. So in the Docker Compose file, for my Java container here, this is my Java container. Here I set some metadata, and the file bit will automatically pick this up and apply these rules. So you don't have to hardwire anything in a file beat configuration, but you set it on the container and it will be applied afterwards, which is also very nice if you have a more dynamic environment where stuff changes around a lot. You can just annotate it on the container. It will contain basically the configuration of how to interact with it. And then you don't have to configure your file beat all the time. But this is maybe not fully inversion of control, but it's a bit like where do you configure stuff and where do you put something. So here I configured that on the container. And this was, by the way, also we had in the slides, two back, we had these hints enabled. This is what the hints are. Basically the labels, in Kubernetes it would be annotations. The labels on the container are applying the right file beat parsing rules so that we don't split up the stack traces. Okay. One other thing that might be tricky otherwise is FileBeat basically keeps track of where you are in a log file in a so-called registry file, which is an inode, a file name, and an offset in that file. And I'm mounting that outside of the FileBeat container. Why would I put that registry file out of the container? So the thing is, if, for example, as the new version of FileBeat is coming out, and I replace my containers with a new version, they wouldn't know what they have already collected in the log files. But with that registry file that is on the host, we would basically know the offset of everything that has been collected by the old version of FileBeat, and it would only collect the stuff that is happening afterwards. So this is to avoid duplicates. And I can also show you what one of these looks like. So for example, here we have a registry file, and then we have the registry. So you see we have the file name. We also have the offset. This is how far we basically got in sending the files along and outside of the container. And it also contains an inode. The nice thing about the inode is, even if you have the file rotation at midnight, and the file rotation happens and you haven't collected the last 3 lines of the log, for example, thanks to the inode, we can still track the file, see, oh, my offset is not at the very end of the file, and it will still send everything out. I have no idea how this works on Windows, unfortunately, because Windows doesn't have this inode concept, but maybe somebody else knows, I don't, I'm not sure how we are tracking stuff there. But this is how we keep track of where we are in the file and that we don't send duplicate events out of our log files. Something I didn't really mention was we still have to do the parsing because we're just writing out a log line again. This time, however, I'm not using Logstash. We could have, but we have a similar concept called ingest node, which you can do in Elasticsearch itself. And you can use the same Croc pattern in Elasticsearch ingest node. You basically say, hey, I collect the data, I send it to the Docker index, and before storing it, please run this pipeline. And I don't hardwire that together to on which this is running. I'm just using the meta information of my index again and say, if it's the Java application, then I know how to parse it. And here, this is the same rule that we've seen before. I'm applying in Elasticsearch, I'm applying the same rule to parse it again. There are some details here to it which don't matter that much for now. Sometimes systems try to be fun and they do that ASCII art when they start up. Is that very helpful when you centralize your logs? Is anybody searching for ASCII art or one line of ASCII art especially? This is basically garbage for any centralized logging system. So what we can do is, for example, we have something, and this here is one block. So we collect the Docker metadata, and then we say, if you're based on the Redis image, then apply this configuration. And basically what we're doing here is, this is the right regular expression to get rid of that ASCII art. It's basically when you're Redis, run these exclude rules to get rid of the ASCII art of Redis and only log the actual statements that Redis is giving you. One thing that might be a bit tricky is when you're in a containerized environment, who logs the logger? Because if your FileBeat that is tailing the Docker logs is writing to the same Docker logs and you have an error in that configuration, it will be a loop, because it's basically outputting its error into the logs, and then it tries to collect it, but runs into its own error, and then is generating another event. So you're basically in a logging loop. What you need to do there is, basically I'm avoiding writing to the system out for my FileBeat, but there I write to a file explicitly. So all the other containers write to system out and end up in the JSON default Docker log, but not FileBeat, because otherwise I would have this logging loop. This one I write to a file. You could mount this outside of the container, so then you could have it outside and you could work with that more easily. Or you just connect to the container and see it. But just to visualize it a bit better, Docker PSA. So we have all our containers, and let's say FileBeat for Elasticsearch, that is the one that is using, that is collecting the JSON events. When I do Docker logs, here you have a lot of output. But when somewhere there must be a FileBeat for something with Docker. Elasticsearch Kibana logs, there's FileBeat Docker for Elasticsearch. This is the one. So this one here, when I run Docker logs, what will I get? Nothing, because it doesn't output there. Because I write to that file, so I avoid that loop. So even if you have a configuration error in that container, it won't create that logging loop. So that's why this is empty and it's written to an actual file that I'm not yet collecting here, just to avoid that loop. Okay, so yeah, containers are what everybody needs to do. But as you can see with the registry file and the last line missing and creating this logging loop, it's kind of a bit more tricky, and you need to think a bit more like how do you actually combine the logging there. The other thing that you can do is how do you log in an orchestrated system. So for example, I assume we're talking about Kubernetes, also because that's what we support best, is where do you put your file beat? In a so-called daemon set. You make sure on every host there is one instance of the file beat running. Otherwise, it's pretty much the same. You're logging to the system out, and it will collect those logs for you and just forward them. We have configuration examples for that because you will write a lot of YAML when you use Kubernetes, and we have examples for those. And you can just start using those. What it generally looks like is, or this is the part how to get to the metadata. If the file beat is running as a daemon set and is part of Kubernetes, it will know where the right API is to query, and you can just say, hey, you're part of the Kubernetes cluster, get the metadata. If you have installed the file beat on the host, so it's not part of your Kubernetes installation, you can still tell it where is the API of Kubernetes to get the metadata. So you use either this one or this block, but this is an XOR, so either the first or the second, depending on where you install it. And then you get metadata, so you would see, for example, we have a namespace, we need to see on which node is this running, which pod does that have, and then you could filter down to those, but otherwise it's pretty much the same as what you're doing with Docker. You have the same templates. This time, to get rid of the ASCII art again, you would have the same, what we had labels with the parsing rules, not to split up the multi-lines, you would have as annotations, so it's just called slightly differently, but it's exactly the same concepts as what we had in Docker. Something that is very nice is you could, for example, store your indices depending on the Kubernetes namespace. What we're doing here is, if there is a Kubernetes namespace, use that Kubernetes namespace as the index name. Otherwise, so this is not a concatenation, but the colon in YAML here, this is this or this, so if this exists, take the namespace, otherwise call it file beat. Then add the beat version, and then we normally do daily index patterns, like to create one index per day. Why are we using daily index patterns? Doesn't that make it very complicated? Why would I create lots of indices? It's mostly for deleting data, because at some point, you will run out of space, or you have a retention policy of X days. And if you have the daily index pattern, it's very easy to delete the data, because you then just say, like, delete that entire day after 30 days, for example. If you would have it in the big index, it's very expensive in Elasticsearch to delete part of an index, because then we would need to merge the rest of the data together, etc. So that's why we have one day, or you could do 1 week or 1 month or whatever. And once you have reached the maximum retention you want to keep your logs, you can just throw away the entire thing afterwards. Why do I add the beat version to that? Why do I have that in the index name? Let's assume there is a new version coming out. And the new version maybe has a change in the mapping. So this is pretty much the schema in a relational database, and we always have a mapping in Elasticsearch. And maybe we want to have a breaking mapping change. If you have the beat version in the index name, you could just switch in the middle of the day. It would create a new index with, this would all be the same, just the beat version would be new. But then you can make a breaking change in the middle of the day without having to try to fix the mapping together. So this is why the version is now in the index name. Otherwise, you would have to wait until midnight and then start with a new mapping for the new day. But this is just to make major version upgrades. Or it includes major and minor version, but it makes version upgrades easier that way. So it's even hotter, but it's even a bit more complex. But yeah, that's up to you. More stuff that might be interesting. We've talked about the index patterns, why time-based and why versioned. Something that people often ask, like, okay, how much space do I need to keep my logs? That is tricky. So the base thing you need to have is, or you need to have an idea is like, what is my daily log volume? What is my retention? And then how many copies do I want to keep of the data? Because for high availability, you probably want to keep more than 1 copy. Normally, you have 2 copies. So if one node dies, you still have the data on another node. What is the right value for retention? Obviously, it depends. Normally, when you talk to anybody and they will say, well, business wants a year. And then you say, okay, let's calculate how much hardware you need for a year. And then they come back and say like, well, maybe 30 days are fine as well. That's the regular thing that we see. Volume-based is, by the way, you need to keep in mind that when you parse data and then store it as JSON, you might have a bit of an overhead. So depending on how compact we can compress your data, etc., you might have a bit more storage size in Elasticsearch than you have in the raw log output. Might be 1 to 1.5 times more, or might be 0 to 50% more of the original value to store it in Elasticsearch, just for a rough sizing idea. And then we have, last week, we have added a new feature that's nice. It's called Index Lifecycle Management. That's the last thing I wanted to show you is you have these policies, and you could have a multi-tiered policy, for example. So you could say, I have a hot phase. This is, for example, today's log data, because only you're writing to today's index. And yesterday's index is read-only because you're writing a new index every day. So this is fast hardware with SSDs and whatever. And then you have a warm phase. This might be yesterday to a week ago, because you're searching that more or less frequently still. And then you have the cold phase, which could be like everything older than a week, because that will be accessed very infrequently, and it could be a bit slower, and that's fine. And then you could have a delete phase where you say, after X days, I just want to delete the data. And you can just click that together in Kibana and then set the right rules. So for example, say, here, no, we don't want to use rollover. Let's say, I want to delete that after, I don't know. Let's say we can keep the data for 30 days. So we set it to 30 days. And then the oldest log data will just be removed for you. And that's how you don't overload your cluster. Okay. Also, we have added something that will make it easier to keep much more data per node. That's also a very new feature. But that would go too far, and we're almost out of time. So to wrap up, you can get all the code on GitHub. You do a Gradle build, you do a Docker Compose up, and that's all you need. And you can run all the examples and just see the things that I've tried out here. Yeah, that's probably the one thing. If you want to take a picture, this is the one you need. We'll publish the slides afterwards, but this is where you get the actual code. We've seen parsing, good old approach, and you don't need to change your application, but parsing is hard, and few people like writing regular expressions. Sending has the downside of you don't need to do any parsing, but if your network is down, you probably don't get any logs, for some time at least. Structuring is a good approach if you don't have containers that you just write out JSON and then you collect those JSON files. Once you're containerized, you don't want to write to a specific file because containers are a bit more short-lived and are moving around faster, so you don't want to wire up, collect this folder and collect this folder, but you just want to write to system out and then collect everything that has been written to system out from the Docker default logs. And then you can run that as a sidecar, or when you orchestrate, you run it as a daemon set. So that all works together nicely. Any questions? And I have a couple of stickers over there on the table if you want to have stickers afterwards, but I think we have like 2 minutes left or so for questions. Does anybody have any questions? Yes, please. I will repeat the question. Why don't we use the logging drivers? So that's a good point. That's something we have been discussing internally a lot. So we don't have a logging driver right now that would speak to the systems that we support. So you could use syslog or gelf, but we don't have an Elasticsearch specific one. The one thing that we didn't want to have is we didn't want to be tied to that specific life cycle of what Docker does. It's because then you have this life cycle of whenever they release, you can add a new feature or whatever you put in there. So we wanted to have a bit more of independence into that. Also, I'm not the actual expert, a colleague is implementing that, but the colleague who was looking into the implementation said all of them are terrible and all of them can lose data in one way or another. And we didn't really want to go into that. Also, you would need to configure that correctly when you set up your containers. So our approach is you just stick to the default Docker JSON log and then you can collect that. But of course, you could use syslog because you could write out from syslog and send it to logstash as well because logstash has a syslog input. You could use gelf. We could input the data into logstash with gelf. If you use journal D, we have a new beat called journal beat, which could get journal D data as well. So those are the alternatives. We don't have a log append or log driver yet for Docker. I'm not sure if you really want to do that tie ourselves into that. We're trying to work around it, but it's a very good question. Any other questions? By the way, before you disappear, I normally try to take a picture with you so I can prove to my colleagues that I've been working. Because they normally don't know where I am. I just travel and do stuff. Smile, everybody, or wave. Wave, thank you. Final questions? No. If you have anything else, or the general search or anything with our stack, just come to me and ask, and I'm happy to answer. Thanks a lot.